On today's lesson, our goal is to write proofs using geometric theorems. First thing we got to do is know these three terms over here. So the first one is proof. What is a proof? Yeah, a logical statement a logical argument. I like that better. That shows what is true? It shows a statement is true. Next one, two-column proof. I like doing a kind of visual example for this. For a two-column proof, I'm going to use this space over to the left. Two-column proof will always have these things. It will have statements, and it will have reasons. We've listed out a lot of reasons in the past, but I want to generally say how they can be classified. So what kinds of things do I put over here? Well, we always start with what word? Okay, we'll have a given. What other kind of things will I put in there without listing out every single... What's that last word that basically comes? Postulate. What's another word that comes at the end of all those? Property. We have postulates. We have properties. We have definitions. These are all types of facts. Yep. One more. And it's written in your definitions. It's written theorems. Occasionally you'll have the word in there simplify, which is not really a property or theorem or definition. So it's the oddball. Given and simplify are kind of like the oddballs. You're always going to have a given, no matter what. You'll occasionally have simplify. It's not real common. So that's an example of what a two-column proof looks like. You have your statements, you have your reasons. These would be some examples of what reasons look like. Next thing is theorem. Theorem. What is a theorem? Okay. So we're just going to say a statement that can be proven. And that'll suffice for right now. The next thing we need to be able to do is look at example 1. So I'll scroll up for that real quick. This one says, use the diagram to prove measure of angle 1 is equal to measure of angle 4. Gives us some given statements and it tells us what we're trying to prove. It also gives a little diagram. What we need to do is we need to check the given statements to see if they have marks that correspond on the picture. So the first given says measure of angle 2 equals the measure of angle 3. Do they have marks on angle 2 and 3? Yes, we do. The next part, measure of AXD equals measure of angle AXC. So AXD and AXC. Do they have marks on those big angles? No, they don't. So we got to add our own marks. So I'm going to put a double mark on AXD. And then I'm going to put the same mark on AXC. I'm going to separate them just a little bit to show you they're two separate angles. Those are the angles we're going to be talking about throughout this proof. I only did that because it was stated in the given. Now this is an easier type of proof because it's kind of fill in the blank. They're helping you out a lot. You'll have some of these on the test, but we're eventually going to work to where you do it all on your own. So whenever they give you fill in the blanks, you got to be really intelligent and get all the points you can get. My first step is to realize the givens. Where are the givens in our two-column proof over here? Where do you see measure of angle 2 equals measure of angle 3? Step 5, yes, good job. It's clearly stated in step 5. There's your given. That shouldn't be hard. There's no thinking. You find it. Where's the other given? Where's the AXD, AXC? That's step 1. So what this is saying is you're not always going to state all your givens right in the beginning. Sometimes they'll wait a little bit and state the other one. All right, from there we can start working on our statements and reasons. The first one says AXD equals 2 angles added together, and it tells us to use angle addition postulate. Angle addition postulate, if you don't remember, is represented by the phrase part plus part equals whole. So what 2 parts should I add up to make AXD? AXD, well, they're numbered over here. What 2 angles do I add up? 1 and 2. Make up AXD. Now it says use the angle addition postulate again for step 3. How do I make up AXC with 2 angles? 3 and 4. Those are not hard steps. The tricky part comes from step 4. You have to put together the previous information, the previous statements that they gave you. How are they able to say 1 plus 2 equals 3 plus 4? I see it right here. How are these related, though? They're congruent, okay. So they are congruent. But are they congruent a reason, a real reason? No, it's not really a property or postulate. What allows us to say that these are equal because these are equal? Substitution. They're replacing, so it's just substitution. So what it's saying is, I know these pieces are equal, so I can set their pieces equal to each other. I can set this part equal to this one, and that's what they do in statement 4. That's the substitution property of equality. Down here we already said statement number 5 is our given. So if they bring it in down here, that means we're probably going to use it in step 6. So now they say 1 plus blank equals 3 plus 4. It looks really similar to step 4, but what changes? They want something to change. What do you think they want to change? Yeah, everywhere you see angle 2, you're going to replace it with angle 3. Oh, there's an angle 2. I'm going to replace it with angle 3. So they used the given to replace. They substituted, and that's exactly the reason they gave. Now the last one. How are they able to go from 6 to 7? That's the question. So something goes on there. You got to look carefully. I'll write it out here. I think it's easier to see out to the side. Angle 1 plus, and I'm going to shorthand it a little bit. Angle 1 plus angle 3 equals angle 3 plus angle 4. They go from there to angle 1 equals angle 4. How do you go from here to here? What happened? This is math, though. We're not cut and repeated. We're not doing transitive. We're not doing law of syllogism. We're not saying if-thens. We're not having a bunch of equal signs. There's only one equal sign. We can't do transitive. This is math. How do you go from here to here? What went away? The 3's went away. Now, what are the 3's doing with the other terms? They're adding. How do you get rid of adding? Subtracting angle 3 from each side will make them go away. What's the property we did right there to make the 3's go away? Perfect. The subtraction property. Good. On these theorems, these are basically things that we've done in the past. So what I want you to do is try to finish out these theorems. The only thing that's changed from the past is that we went from an equal sign to congruent symbols. So they're no longer equals here. They're congruent symbols. See if you can do this on your own. Go. Do them on your own. If you can't do them, that means you have a lot of studying to do. You shouldn't need notes. You should not need your book. You should be able to do these without your notes and without your book. If you can't, that's a bad situation. Let's get them written down. Let's do these. Fill in all those blanks in that box. This shouldn't be hard. You're not doing it. Yeah, don't be changing the order, and you dropped a lot of angle symbols and segment symbols up here. Don't forget your segment symbols and your tilde. That's not good notation right there. No. No, no, no. No. Angle symbol. Angle symbol. No. All right, here we go. So for these theorems, reflexive, you should remember AB is congruent to itself. The phrase once again was, it equals itself, which some of you need to study. Symmetric, what was the little phrase for that one? Switch or flip. Good job. Switch or flip. So it's now CD is congruent to AB, and these are both segments, so they get the segment symbol over top. The last one, transitive, it's the one most of us liked a lot. Cut repeats, right to left over. Cut repeats, right left over. So here's the repeats. Cut the repeats and write the left over. AB, segment AB, is congruent to segment EF. How many total congruent symbols? 3. So that should help us remember. RST, 1, 2, 3. Hopefully you remember that. There aren't 3 equal signs being used or 3 congruent symbols. You're probably not using transitive. These down here deal with angles. Up here it was segments, so we use the segment symbol. Down here they're angles, so we're going to use the angle symbol. So reflexive means it equals itself. Angle A is congruent to angle A. Notice I didn't put the little m. I didn't put measure because we're not talking about being equal to a number. Over here, symmetric, we switch them or flip them. So angle B is congruent to angle A. And the third one, cut the repeats and write what's left. So angle A is congruent to angle C. And I will be very picky on angle symbols and segment symbols, so you need to know when they're appropriate and when they're not. Most of the time, it's pretty much indicated in some other part of the problem what should you be saying. All right, example 2, this is a real quick one. What's going on here in example 2? This is the symmetric property. How do you get that so quickly? They're just flipping them. And once again, switch or flip, that's symmetric. You could also remember it by two congruent signs, RST 1, 2, 3. Good job. Now I'm going to give you a little bit of time to work on this next checkpoint. Let's see if you can get these finished. I'll give you time. All right, here we go. On the checkpoint, it says, 3 steps of a proof are shown. Give the reasons for the last 2 steps. It gave you the given. It's stated up here, and it's indicated in the picture. We're trying to prove AC is equal to AB plus AB. So the first thing we need to do is see, where did this come from? AC, that's the total thing, equals AB plus BC. This should be very evident what that is. That's segment addition postulate, part plus part equals whole. If you missed that, you need to study. That means you're a little bit behind if you're missing that. You should recognize that because we've used that about 4 days now. Part plus part equals whole. That's exactly what it's doing. But then they go from 2 to 3 and something changes. One term changes. What changed? BC changed to, when you just replace one thing with something you know is already equal, that's called substitution. We just replaced one term. That's substitution. Last one, name the property illustrated. Pretty much everybody got this right. I think I only saw one person miss it. What's going on here? This is the transitive property. How do you know it's transitive property? 3 equals sign. What else? Cut the repeats and write leftover is what I was kind of looking for. So yeah. All right. Next part. So we have example 3. On this one, we have a lot of good stuff. All these properties that we're using today, guaranteed they're on the test. All these types of proofs we're doing today, guaranteed on the test. These are solid proofs. On example 3, it says, if you know that ray BD bisects angle ABC, prove that measure of angle ABC is 2 times the measure of angle 1. So first thing, it gives us a given statement. BD bisects angle ABC. Obviously, that's our given. That's easy points. If you miss that, you're missing easy points. But I always tell you, check to see, is your given statement drawn or noted on the picture somehow? How? Where? I don't see any marks on the picture. I'm talking about, is the given marked on the diagram? It's not right now, but we have to do it then. So what kind of mark should we put? What does it mean to bisect an angle? Cut it into 2 equal parts. You need to write that down if you don't know what bisect means. Bisect means to cut into 2 equal parts. It does not mean cut in half. We don't like that term cut in half. We like cut into 2 equal parts because that tells us what to draw in the picture. These are our 2 equal parts. I put 2 separate congruent arcs on them, showing those 2 angles are congruent. From there, we need to actually state what we just drew on the picture. It says that's actually the definition of an angle bisector. The definition says we cut it into 2 equal parts. What 2 parts are equal on the picture? Use the numbers. Angle 1 is congruent to angle 2. Now, there's one other definition that we haven't used a lot, and it's really kind of silly, but seen occasionally through here. It's called the definition of congruence. Sometimes I'll abbreviate and just put definition of congruence. That's all I'll write sometimes. What it does is it takes a congruent symbol and changes it to an equal symbol. But remember, when you say equals, you need to put the little m. Measure of angle, measure of angle. That's all the definition of congruence does. Changes from a congruence to an equals or vice versa. The same thing can be done for segments. We still just call it definition of congruence. Pretty simple. The next part is step 4. They say angle 1 plus angle 2 equals ABC. This is a pattern we should have seen a lot of. Oh, so I'm hearing something addition postulate. Angle addition. Let's see if it holds true. Angle 1 plus angle 2 is ABC. If I add this one plus this one, then I should get ABC. Yes, that's true. That is the angle addition postulate. Why would you not say segment addition postulate here? They're not segments. That's pretty simple. All right, now it says, all right, substitution. We're going to be substituting. The 1 stays the same. The ABC stays the same. I need to change the 2 to all right, and I can do that because of statement 3. These 2 can be replaced for each other all day long. I can change the 2 to a 1. That's substitution. Last step is statement number 6, and it's distributive property. Some people struggle on seeing this one. But adding something to itself is the same as doing 2 times itself. 2 times the measure of angle 1 is measure of angle ABC. That is the distributive property. It's just showing it in a different way. It's kind of weird to see it like that, but that's actually what's going on. Good job. Example 4 is our last example we're doing today. It says there are 2 exits between the rest areas on a stretch of interstate. A Rice exit is halfway between rest area A and Mason exit. The distance between the rest area B and the Mason exit is the same as the distance between rest area A and the Rice exit. Prove that the Mason exit is halfway between Rice exit and rest area B. Whew. Lots of stuff. They give you a paragraph in a real life situation, but they give you a hint. First thing you need to do is draw it out. A lot of these, if you just draw it out, it's not that hard. So that's what we're going to begin with. Out here to the side in the margin, we're going to draw what's verbally stated. So first thing, there are 2 exits between rest areas. So it's going to kind of look like this. We have 2 rest areas, and then we have 2 other stops in between them. That's exactly what they say. There are 2 exits between rest areas. But now I just need to label them with the appropriate parts. So we're on sentence number 2 now. The Rice exit is halfway between rest area A and the Mason exit. So remember, it did say the rest areas are on the ends. So there's rest area A, and the Rice exit is halfway between A and the Mason exit. On down it says the distance between rest area B and Mason. Oh, we don't have a B. Oh, remember rest area is on the other ends. So once again, it's Rice. We have Mason. And we have our rest area B. We have our rest area A. Once again, the distance between rest area B and Mason is the same as the distance between A and Rice. So we're forgetting something. Even if you got this, we're missing some marks. What kind of marks am I talking about? Congruent marks. So we got to figure out, did we put any marks on there? No. So where should they be? Back to sentence 2. Read that one. Rice exit is halfway between rest area A and Mason. Where should I put congruent marks? A and R. Also, Rice and M. It's halfway between A and M. Good. The next one, the distance between B and Mason is the same as A and Rice. So this distance is the same as this one. So it should also have a single mark. So it's putting it all together. You have to read and understand what it's saying. So this is comprehension. From there, we're going to be doing some proofs. So we got to remember that picture and use it. So first off, I'll try to scroll up a little bit. Let's do the first few statements. It says, R is the midpoint of AM, MB equals AR. Where is that stated? Hey, guess what? It tells you that's a given. From there, it says use the definition of a midpoint. Use what you know about a midpoint. Well, it says R is the midpoint of AM. What did that allow us to draw up here in the picture? Congruent marks. What pieces were congruent? AR and RM. AR is equal to RM. Technically, we should be doing congruence. AR, the segment, is congruent to segment RM. That way we can do the silly one they say in step 3. Definition of congruence is what they ask us to do in step 3. What's that do? Changes it to an equals. So it's what I wrote down the first time. But then they say MB equals RM. MB equals RM. MB equals RM. That's not in the given. That's not stated in the given. So why can... This is substitution, and I'll show you why. This is the substitution property, and I'll highlight it. This should look familiar, and this should look familiar. How do they go from these two to that? Yeah, they replace something. Anywhere I see an MB, I can replace it with an AR. Or anywhere I see an AR, I can replace it with an RM. That's exactly what they do. They found an AR, which is right here, and replaced it with an RM. That's how they got this. That's substitution. They replaced one thing with another. Next one says definition of what? That's definition of congruence. So remember, definition of congruence is that silly one. All they do is change equals to a congruence. I agree, that one is silly. The last one they say down there, it's cut off on my page. They say the statement M is the midpoint. So this piece right here, M is the midpoint of RB. Why can I say that? Because why? We've already seen it once more. This is definition of a midpoint. And we're done with that one.